Yeah, students, now we will see the next unit, unit number 2, where we are going to see the projections of straight lines, and we will see the content of second unit, and we will proceed to the first topic, straight lines, projections of straight lines. So these are the contents of unit number 2, orthographic projection, first angle projection. Already we have seen what is first angle projection, what do you mean by orthographic projection and its importance, why first angle projection is used in engineering drawing. All those things we have seen in earlier unit. Now we will straight away start the projections of straight lines inclined to both the principal planes, as well as there are six positions of lines. All those are required for this unit. We will discuss one by one. Projections of straight lines, determination of true lengths and true inclinations by rotating line method only. So there are two methods to solve these type of problems. When the line is inclined to both the planes, there are actually two methods to solve it. One is rotating line method, another one is trapezoidal method. We are going to discuss only rotating line method. Projections of planes, plane surfaces are of polygonal and circular surfaces. We are going to discuss that in next session. Inclined to one of the principal planes and perpendicular to other by rotating object method. So in earlier case we are about to see the rotating line method, whereas here rotating object method. So here also there is one more method, we have auxiliary plane method. So instead of rotating object, the principal plane itself can be rotated, and on that we can grab the front view as well as the top view, whereas here we are going to see rotating object method only. So that is the content. To solve this type of problems, and first we will initially see the straight line inclined to one plane, up to one plane. When we start the straight line inclined to both the planes, there we need a few more data that we will discuss soon. To solve the first five cases, I will show you what are all the first five cases. To solve these five cases, we need this data. So in this session we will see the simple cases of lines. Those are of five types, and one special case, that is of line inclined to both the planes, in next session. So true length is required. So to solve these five types, so that is the initial five types, we are going to use this data only. True length or apparent length. True length is the actual length of the line, and apparent length is the projection. So we can measure along the projection that it is not the true length, as well as the apparent length is always lesser than true length. So apparent length is measured along its projection. Position of its ends with relevant to HP and VP. So with respect to these two principal planes, we are going to define the position. The position will be given in the problem statement. With that, we are going to locate the first end. Either first end or second end, both can be defined, and both can be positioned with respect to these two planes, and that position is very important. Without that we cannot proceed to solve these type of problems. Its inclinations with HP and VP. Inclinations are there are two inclinations right now. One is theta, that is the inclination with respect to HP. Phi, that is the inclination with respect to VP. Only these two we are going to discuss now. Yeah, coming to notations, these are the notations we use. The line AB is nothing but the true line, actual line. The actual line in space, that is represented with capital letters AB. So that is the true line. True line is AB, or we can say it is actual line, and its front view is A dash B dash. Front view is A dash B dash, and anywhere when you represent a front view, you should notate with dash only, that is A dash B dash. Its top view is AB, side view is A double dash B double dash. Its inclination with HP is theta, and the inclination with VP is phi. Coming to positions of line in first quadrant, a line perpendicular to HP and parallel to VP. So these are the ways we can keep a line in first quadrant or in any of the quadrants, but especially we are dealing with the first quadrant. A line perpendicular to HP and parallel to VP. I will show you all these positions. A line perpendicular to VP and parallel to HP. A line parallel to both HP and VP. A line inclined to HP and parallel to VP. A line inclined to VP and parallel to HP. And the special case is the sixth one. A line inclined to both reference planes. So this is our next topic. This itself is the next topic we are going to discuss in detail. And up to fifth case, these can be categorized as simple cases. So we will see the first case. A line perpendicular to HP and parallel to VP. So a line is perpendicular to HP and parallel to VP. So if you take any line object like a pen or a scale, you can just place it a vertical to ground or vertical to table becomes HP, and the corresponding any plane, a standing wall or any planar surface, so that can be considered as VP, and I will show you its positions. This is HP and this is VP. So this is the plane HP and this is the VP plane. These two are called as principal planes, and the line that connects both HP and VP is known as XY reference line. Always observer stands in front of first quadrant. So now this is the line, this is the actual line. So that is why it is represented as AB, and its corresponding front view is projected onto vertical plane. So this is the front view. It is notated with smaller case AB, A dash B dash. So this becomes our front view now. And the top view, if you see from top in this first quadrant, and observer is here only, so with respect to him, the top view, if you see from top, A point is visible and B point becomes invisible. So obviously A and B are lying at the same point, because only a point we can see, this end we can see, point A can be seen. So point A overlaps point B. So one point is invisible point, another point is visible point. Now we can see the projection. So this is known as projector. This is known as projector, and we see here, this is A is visible, and B within bracket, whatever letter, whatever notation that you find within brackets, it is known as invisible point. Always invisible point should be represented within brackets. So this is how you should notate. So this is front view and this is the top view. So the front view, from front view to top view, that connector is known as projector. The B dash and B dash to B and A dash to A, actually you will get two projectors in case A and B are separately placed, whereas here you are getting a single projector with which you need to get A, B. So that is top view. So here this is the planar representation. Now if you want to draw on the drawing sheet, right, so you have to turn this horizontal plane 90-degree clockwise. So that is our orthographic rule, so that already we have discussed. And if you rotate this horizontal plane 90-degree clockwise, now this line will become a straight line. So it means that we are doing a simple exercise to transfer the front view and top view onto our drawing sheet. So that is nothing but a pictorial orthographic projection. So this is orthographic projection. So here it is our plain paper or drawing sheet, we can consider, and draw this XY reference line first. So this is the XY reference line. So the theme of representing a vertical plane and a horizontal plane. So above this XY reference line we have VP, so that is VP. Below XY reference line we have HP. So this is the theme to represent first angle projection. Now whatever point A you have, right, that should be called as the point A above HP, the distance of point A above HP, and with respect to point B, the distance of point B above HP. So these two data we need to draw A dash and B dash. So that data will be given in the problem statement, so no need to worry about it. So this should be drawn here, so that this is nothing but your front view. So this is your A dash, this is A dash, and this is your B dash. And from A dash and B dash, so it is lying on the same straight line, so a single projector will be sufficient to represent its top view. So from here draw a thin line, it should be thin line, so all projectors should be thin lines, and finally we mark a point. So that point is nothing but this is the point, this is the end point we can see in the top view. So that becomes A comma within bracket B, within bracket B. So this is the orthographic projection of the line when it is perpendicular to HP and parallel to VP. So this is the first case and first type of line position in first quadrant. So this is the orthographic projection as well as the actual planar representation. So with which, right, you should be clear to mark the points with respect to XY reference line. So the point A is now above HP, point B is above HP, here point A in front of VP. So this distance is in front of VP distance and this distance is above HP distance. So that you should remember throughout your lines exercises. So coming to next position. So this is HP and this is VP, right? So similarly we have XY reference line, observer, and this is the line. Now this is the line perpendicular to VP and parallel to HP, parallel to HP. So this is the top view. When you see from top, right, you can see the actual length. So when the line is parallel to HP or parallel to VP, the corresponding projection is will contain the same length. So whatever length you have, AB length, the same length is observed in top view also. So this becomes your top view. So as usual, the top view is represented with smaller case letter A and smaller case letter B, and this is your corresponding front view. So this is your front view. So A is visible and B is invisible. So A dash is without bracket and B is invisible point, that should be within bracket. So this is your planar representation of this case when the line is perpendicular to VP and parallel to HP. And now we will try to transfer this onto our drawing sheet as we did in earlier case. So this is your XY reference line. This is the theme to represent the first angle projection. This is your top view. This is top view, and this distance is in front of VP distance. So this is our in front of VP distance, and above HP. Above HP is this is the distance where you can see a point, and from here draw the projector and mark the point and notate it A dash and B dash. B dash should be within bracket. So this is the line when it is perpendicular to VP and. So coming to the third case, a line parallel to both HP and VP. So this is a peculiar case where the front view and top view we can see the true length itself. So that is the speciality of this position. And we have observer, we have HP, we have VP, AB. So this is the AB line. AB is capital letters, so it is the actual line. So the corresponding top view is AB, so this is AB, and this is top view, and the corresponding front view will also have the same length. The top view length and front view length will be the same, so that is the significance of this position. So this is B dash and this is A dash. We have front view and we have top view. So this is the planar representation. To transfer this onto our drawing sheet, this is the scheme. XY reference line, and we have VP above XY reference line, HP below XY reference line, and this is the top view in front of VP distance. This should be drawn at a distance from VP vertical plane, and above HP we have front view, and this is AB. The corresponding front view is A dash B dash, and this is the simple case. This is another simple case where we have not seen the angle edge. So in next case I am going to introduce the theta, the notation theta. So the next simple case is a line inclined to HP and parallel to VP. So here this is the pictorial representation where this is your HP and this is your VP, and the line is inclined to HP, so that is theta. So in front view we can see its actual length. So in front view we can see its actual length, and this is your front view. So A dash B dash will be equal to capital AB line. So this is the front view since it is parallel to VP. On whenever the line is parallel to a particular plane, on that plane we can see its true length. So now it is inclined to HP. It is inclined to HP. When you see from top, you cannot see the true length. It is obviously a slant line. So the projection will become a straight line with a reduced length. That length is known as apparent length. So this is known as apparent length. So now we are getting the term apparent length. So theta is represented in front view only. Theta is with respect to HP. So the inclination with HP is represented on VP. So we can show this only on VP, and the corresponding top view is now this much only. So we have this reduced length. That length is known as apparent length. So now the top view is smaller length. It is having smaller length. So AB is the top view, where if you measure and compare with the actual length, it will be a reduced length because of this theta angle. If you keep increasing this theta, the length will becoming decrease. The length will be decreased, by increasing this theta. By reducing theta, when theta becomes 0, so there is no doubt it will be of same length. AB will be with the same length. When theta is equal to 90 degrees, students, then you can see a point only. So the length from 0 degree to 90 degree becoming reduced. So it is reduced to 0 from actual length to 0. So that is the significance of theta angle, and the corresponding top view will have the reduced length. So please remember the word apparent length. So it is apparent length. So in next case, in next special case, that is the last case, line inclined to both the planes, there we are going to have this apparent length, and we are going to use apparent length to solve problems also. So that we will see, and we will transfer this onto our drawing sheet. So this is our XY reference line, VP, HP, and in front of VP we have AB, and above HP we have A dash B dash at theta angle. So that is the theta. Always the true length line should be drawn first, always. So to start any problem, you have to start with the true length line in case of lines. So in case of planes, that we will discuss later, there also we have to start with true shape. Wherever we can see the true shape, from that plane we should start to solve our problem. So this is theta, and this is our front view. So this is obviously with the true length only. So this is our A dash B dash. So the corresponding top view is of with apparent length AB. So AB. So this is our front view and top view when the line is inclined to HP and parallel to VP. Now we will see the next case, a line inclined to VP and parallel to HP. So this is the vice versa to last case. In last case we have seen the line is inclined to HP and parallel to VP, whereas here the line is inclined to VP. So that angle is known as phi. This is phi. This is phi, and this is the true line, and the corresponding front view is a apparent length, right? Apparent length. In top view you can see the true length. In top view you can see the true length, and you have to start from top view only. To draw on the drawing sheet, you should start with the top view and you should end up with front view. So this is your front view A dash B dash. The corresponding top view is this, the actual line, the actual length line, and this is your top view. This is your top view. Top view will have the same length as capital AB, and whereas A dash B dash is at reduced length just because of the angle phi. So similarly here, when phi is 0, the front view will be having the same length as AB, whereas when phi becomes 90 degree, and AB distance will become, A dash B dash distance will become 0. So where you can see a point only. So to transfer on drawing sheet, this is the scheme, XY reference line, VP, HP, and always you should draw the true length line. So this is our top view, AB, and front view is A dash B dash. So A dash B dash is our apparent length, and AB is our true length. So that is the front, that is known as apparent length. So these are the two lengths we can see here. So next is a line inclined to both HP and VP. It is a very special case. We need to have a set of procedure to solve these problems. So before starting this case, right? So this case we will be discussing in next session. and just I will show you the representation only. So when the line is inclined to VP and HP, and we have both alpha and beta, right? So this is the alpha angle. Alpha angle is apparent angle, and beta is also apparent angle. Now the line is inclined to both HP and VP, A, B, capital AB, right? So the line AB is, when it is inclined to, when we transfer onto our drawing sheet, we will be getting alpha and beta, angles. I will introduce it later, need to worry right now. So problems, to solve these problems, a line AB 75 mm long is parallel to both HP and VP. Point A, so in position is given here. Point A is 25 mm above HP, and point B is 40 mm in front of VP. Since the line is parallel to both HP and VP, and when the point A is at 25 mm above HP, it means that point B is also 25 mm above HP. Similarly here, when point B is 40 mm in front of VP, it means that point A is also 40 mm in front of VP. So draw its projections. It means that we have to draw both top view and front view, or in some cases they may mention to draw the plan and elevation. So it is also same. Plan is nothing but your top view, and elevation is nothing but your front view. So in a few problem statements you may find the terminology also. So we need to draw only front view and top view, no question of side view, no need to worry about side view. So as usual, to start this problem, draw XY reference line first, and name it as XY reference line. Above XY reference line VP and HP, and 25 mm above HP, and measure this and mark 25 mm, and draw a thin line of any length. For drawing thin lines there is no restriction, you can draw a number of thin lines. So point A is 25 mm above HP, so B also will be on this line only, so there is no doubt. So here above 25 mm from HP, right, we have this front view, so that is a front view, and at 40 mm we are going to have A and B also, so this is the line length is given 75 mm, and I have drawn a line on which I am going to have the first point. So this is the point where I am going to have A dash, and this is the point where I am going to have A. So from this point I measure 70 mm, 75 mm, because the true length is 75 mm. So in this case top view also will have the same 75 mm, and front view will also have the same 75 mm length. So I have drawn one more projector. So everything I have finished. Only thing is I need to draw thick lines to represent our front view as well as top view. So here this becomes your front view, and this becomes the top view, and this is our A dash, and this is our B dash, and this is our front view A dash B dash, and this is our top view AB. So this is the solution. This is how you should proceed. Whereas here both are true length lines. Either you can draw front view first and top view next, or you can draw top view first and front view next. So in either way you can proceed. There is no problem. You will get the same answer. So this is the first problem. A dash B dash is the front view, A B is the top view, and don't forget to mention the all dimensions are in mm. Only one unit we are using here, that is millimeters. So this is how we should write and show all dimensions are in mm should be in smaller case letters only. So next problem, a CD 60 mm long is contained by HP and 20 mm in front of VP. Draw its projections. So this is a XY reference line, and here it is contained by HP and 20 mm in front of VP. So here also the kind of problem where it belongs to the same case. A line is parallel to both the planes, but the line is contained by HP. When it is on HP, on front view you can see on HP itself, that is on it will fall on XY reference line itself, because the front view is observed along your VP, along your HP. So on XY reference line you are going to get the front view. At 20 mm distance you are going to get the top view. Since the line is contained by HP, in top view you can see the in front of VP distance, and on XY reference line you can see the front view. So that is the speciality of this problem, because the line is contained by HP. So front view is obtained on HP itself. It means that on XY reference line in this case, and whereas the front view, the top view is obtained at 20 mm in front of VP. At 20 mm you draw a thin line and first draw the skeleton, and the line is 60 mm. At 60 mm you draw one more projector. So this becomes your A dash. Sorry, it is C dash, and it is D dash, whereas this will be your corresponding C, top view, and this is your corresponding D. So this is this is the top view, and this will become your front view. Front view is on HP itself, on XY reference line itself. So that is the importance of this problem. So C dash D dash is the front view, CD is the top view, all dimensions are in mm. And coming to next problem, a line PQ, and notations, there are different notations, whatever it may be. The front view should be notated with a dash, and top view should be notated without dash. And a line PQ 75 mm long is contained by VP. So here the line is contained by VP and in front of and above HP, 30 mm above HP. So there is no in front of distance, and it is 30 mm above HP. And front view is above XY reference line, and top view, because it is contained by VP, it is lying on VP itself. So when you see from top, it is lying on VP itself, so you have to draw on XY reference line. So it is also similar kind of problem where we have seen in earlier case. So this is your XY reference line. Above 30 mm we are going to see its front view. Top view will be recorded on XY reference line itself. So the line length, PQ length is 75 mm. At 75 mm you draw two parallel projectors, right? And the above HP distance is given 30 mm. Measure 30 mm and draw one thin line where our P dash Q dash will lie, and this is your P dash, and this will become your Q dash. Draw thick line to connect P dash and Q dash, and this is your P top view, because top view is on VP itself. So there is no in front of VP distance, it is 0, and this is our Q. So P dash and P is the front view and top view of first point, and front view and top view of second point is Q dash and Q respectively. So this is the problem. So these three problems are having three significant changes in data. So next problem, a line EF 70 mm long is perpendicular to HP and parallel to VP. One end of the line E is 15 mm above HP and 30 mm in front of VP. Draw its projections. So that is the line is perpendicular to HP and parallel to VP. So here it is the first case where we have seen we have got the demonstration of planar positions, and the line is parallel to VP and perpendicular to HP, and we have to start. So this is the customary requirement. We have to start the problem from the true length line. One end of the line E is 15 mm above HP and 30 mm in front of VP. So one end of the line E, right? So the first point E is lying at 15 mm above HP and 30 mm in front of VP. Draw its projections. So projections are nothing but here top view and front view. So it is of this kind. It is perpendicular to HP and parallel to VP. So first you underline that and start the problem. So this is the XY reference line. We have VP and HP. Draw a single projector because we are going to have only one projector on which we will have the final projections. So you have to start with the true length line. So where will you get the true length line? Here it is obviously in front view because it is parallel to VP and perpendicular to HP. So when you see from top, when it is perpendicular to HP, you are going to see as a point only. The top view will be a point. So this is the 15 mm above HP and 30 mm in front of VP, right? We will mark that, and this is your first point E. So this is your E dash, and we have to start with the true length line only, E dash, and this is our 70 mm E. So sorry, F dash. So this is our front view. This is the front view, E dash and F dash. The corresponding top view will be at 30 mm. So both points will be at the same distance in front of VP, that is 30 mm. So measure 30 mm and draw a thin line, and now E dash is within bracket. When you see from top, E dash is invisible, F dash is visible. So F end is visible, so F should be without bracket. And now both E and F are lying at the same distance, 30 mm in front of VP. All dimensions are in mm. A line GH has one of its end G on HP and 15 mm in front of VP. The other end H is 65 mm above HP. Draw its projections when the line is perpendicular to HP and parallel to VP. So here the line is perpendicular to HP, so parallel to VP, and the end positions are given. So the true line is GH and G is on HP. So one end is on HP itself and 15 mm in front of VP. So G is 15 mm in front of VP, but it is on HP. It is contained by HP. So one end is on HP. So it is also similar to earlier problem. Only difference is the G is on HP. G is on HP, and but G is in front of VP by 15 mm. It is at this distance. The other end H is 65 mm above HP. So other end H is 65 mm above HP. It means that it is G is on HP and H is 65 mm above HP. It means that the GH length itself is 65 mm long, right? So the true length is 65 mm above HP. Draw its projections when the line is perpendicular to HP and parallel to VP. So that is the type of this kind. So it is also like earlier problem. So here in front view, right, the G point is lying on HP. So G dash should be on XY reference line, right? And the H point is 65 mm above HP. So draw one more line at 65 mm. So G dash is on HP, 65 mm above XY reference line. So this becomes your H dash. So you are starting with a true length line. So true length line, and this is 15 mm. This is GH, and G is invisible, so G should be within bracket, and H is visible and H is without bracket. So this is our front view and this is our top view. So this is the problem where the difference between earlier problem and this problem is the G is contained by HP. G is lying on HP, and it is the line kept on HP vertically. So that is the case. So that is about 7th problem. We will see the next problem. The next problem is a line IJ 75 mm long is perpendicular to VP and parallel to HP. Draw its projections when one of its end I is 15 mm above HP and 20 mm in front of VP. So here this is the kind of problem. It is perpendicular to VP and parallel to HP. Perpendicular to VP. When it is perpendicular to VP, the front view is a point, and parallel to HP, so true length can be observed on HP. So that is the way you should start your problem. Try its projections when one of its end I is 15 mm above HP and 20 mm in front of VP. So the front view is obviously a point, 25 mm that is 15 mm above HP. 15 mm above HP and 20 mm in front of VP. So the top view you have to start from 20 mm in front of VP and 15 mm above HP, that is for front view. So to start this problem, now we have to start from true length line. So true length is observed in top view only. So top view, first mark the point end I 15 mm, sorry 20 mm in front of VP. So 20 mm in front of VP. So first mark 20 mm and mark the first point, that is I. So this is your I, and the true length is 75 mm. So draw the top view. So this is the top view and draw a 75 mm line. So this will be your top view. So this is the top view. The corresponding front view is a point. So I is invisible and J is visible. So just mark a point at 15 mm, that becomes your front view. So I is within bracket, J is without bracket. So this is the front view. So you have to start the problem with the true length line. That is very important. As usual, mention the all dimensions are in mm. So this is the kind of problem where the line is perpendicular to VP and parallel to HP. So here a line MN is perpendicular to VP and parallel to HP. So it is also similar to earlier problem. One end of the line is 20 mm above HP, 25 mm in front of VP. So here the front view is a point because it is perpendicular to VP. So front view will be a point parallel to HP. So true length line can be observed on HP. It is nothing but top view. One end of the line is 20 mm above HP, 25 mm in front of VP, and the other end is 75 mm in front of VP. Draw its projections and determine its length. So true length you have to determine, you have to find. So it is very simple to find true length because the other end is given. The one end of the line in front of VP is given 25 mm and the other end is 75 mm. So M is at 25 mm and N is at 75 mm. So 75 minus 25 will become the true length. So that can be determined graphically. Now we will see how to find the true length. So draw XY reference line. So above HP is 20 mm. Draw a line at 20 mm and one end is 25 mm in front of VP. So this is 25 mm and mark the first point. So that is M, and another end is at 75 mm. So 75 mm from VP. So 75 minus 25, that becomes our true length. So at 75 mm draw the line. So now this is your MN. So it means that this is the true length line. So this is the top view also. The top view. The front view is 20 mm. Sorry, the 20 mm above HP, 25 mm in front of VP. The other end is, so one end is 20 mm above HP. So above HP, where we are going to see the front view, at 20 mm draw a line and mark a point. So M is invisible and N is visible. So this is your front view and this is the top view. So it is also like earlier problem only. Only thing is the true length you need to find. You need to find. So that is 50 mm. So you draw that 50 mm separately, right? So this is your x. X is equal to 50 mm. 50 mm. Now, as usual, mention all dimensions are in mm. So this is your next problem. So the 10th one, a line PQ 65 mm long is inclined at 45 degrees to HP. So this is next type. We are moving to it is fourth type, and fourth case where the line is inclined to HP and parallel to VP. So whenever it is parallel, on that plane we can see the true shape, true line. So it is inclined at 45 degrees to HP. So on HP we are going to get the top view. It is obviously an apparent length line. So it is having apparent length only. The NP is 25 mm above HP, 20 mm in front of VP. So one end is given, that is 25 mm, and 20 mm in front of VP. So that is the top view, in top view of the same point P. Draw the projections of the line PQ. So true length is given, 45 degrees is also given, and that is theta. Theta equal to 45 degrees. The NP is 25 mm above HP and 20 mm in front of VP. Draw the projections of the PQ line. So at the above HP is 25 mm. At 25 mm draw a line, and in front view only you can see the true shape or true length line. So at 45 degrees draw a line. So on this line, on 25 mm line, draw a 45 degree line by marking a point anywhere on this line, thin line. So mark a point P dash, and at 45 degrees with a length of 65 mm draw a line. So the draw a line of length 65 mm. So this is your front view, with that should be drawn with thick lines. So from P dash drop down a thin line, and from Q dash drop down with a thin line, draw a thin line, and at in front of VP 20 mm is given. In front of VP 20 mm is given. That is obviously end P, but Q also will be on the 20 mm line only. So at 20 mm draw a thin line. So you will have P here, and the corresponding Q dash you will obtain here. So that is the top view. That is the top view. This is the top view, and as usual represent all dimensions are in mm. So this is another kind, right? And we will move to next problem. One end R of line RS is 20 mm above HP. So one end is 20 mm above HP and 25 mm in front of VP. The other end is 60 mm above HP. Draw its projections when the top view of the line measures 60 mm. So top view length is given and no angle is given. It is obviously inclined to HP and parallel to VP. So parallel to VP, the top view length, that is nothing but AB length is given. Smaller case AB length is 60 mm. Also determine the true length of the line and angle of inclination of the line with HP. So that is very simple, and it is also of last type only. So whereas here no true length is given, you have to find the true length from 60 mm, from the top view 60 mm, but the ends of the line in front view, right, both ends are given here. So the distance above HP is given. So here the other end is 60 mm above HP, right? So one end is the 20 mm above HP, right? So one end is 20 mm above HP and other end is 60 mm above HP. So these two data is sufficient to find the true length of the line. So let us start the problem. First you mark R point. So that is 20 mm above HP, right? And 25 mm in front of VP. So that is the first point. You mark the first point. So that is 20 mm above HP and 60 mm above HP. Other end is 60 mm above HP. So at 20 mm you draw a thin line. At 60 mm also you draw a thin line. So somewhere here my true length line I will obtain, right? I can obtain somewhere here. So draw thin lines, no problem. You can draw a number of thin lines. So one end is at 20 mm above HP and other end is 60 mm above HP. So the first end, that is R, is 25 mm in front of VP is also given. So after 25 mm you draw a thin line. After 25 mm you draw a thin line. So on this line my top view is going to lie. So top view distance is also given. So that is 60 mm. So as per our orthographic rules, the apparent length should be lesser than the true length line. So the true length is obviously greater than the 60 mm. There is no doubt. If you are getting anything lesser than 60, it means that your problem is not correct. So now draw the top view. So you mark a point. So first you mark the first point R, right? So given data, first we will mark all the given data, and R dash, the corresponding top view of this R dash is R. So mark R. So this is R, right? Smaller case letter R. So from R you draw 60 mm thick line. Straight away you can draw thick line 60 mm. So this is your top view. This is your top view. From S, right, you draw a thin line till it meets the 60 mm line, right? 60 mm line from XY reference line. You draw a thin line. You mark the arrow mark also, because it means that you are projecting in this direction, right? So this arrow mark plays a significant role, right? Later on you can also easily understand, right, by seeing this arrow mark. So you please mark this arrow. From R dash you draw a line to join this intersection point, right? So this can be straight away thick line. So R dash and R. So this is the true length line. S dash. So S dash, now R dash S dash will become your true length line. So this is your true length line. So this is the factor, X factor we need to find. We don't know how much X is. It should be, right, greater than 60 mm. So measure X and angle theta. So this theta and X are two unknowns. We are finding out from here, right, in reverse order. So X I am getting 72 mm and theta I am getting 35 degree. Students, if you are getting anything, right, more than or lesser than 72 or anything that differ from 35 degree, please let me know. I will cross check my answer. So this is the answers I am getting. Please check this and verify your answer also. So that is the 11th problem. And next problem we will see the line inclined to VP, right? The line inclined to VP and parallel to HP. So a line AB 55 mm long is parallel to HP and inclined at 35 degrees to VP. It means that phi angle is given, that is 35 degree to VP. The end A is 20 mm above HP and 15 mm in front of VP. So draw its projections. So it is of this kind. The problem is straightforward. There is nothing to find here. With the available data, we need to show the front view and top view. The line AB is 55 mm long, is parallel to HP and inclined at 35 degrees to VP, right? It is nothing but phi angle, phi. So the NDA is 20 mm above HP and 15 mm in front of VP. Draw its projections. So obviously in top view you are going to see the true length. So you have to start from top view first. So start the problem with the top view. and first mark the point end A 20 mm above HP, and you have 15 mm in front of VP, right? So 15 mm in front of VP, that is point A. So A dash you can mark somewhere here, and that becomes A dash, and this is your A dash and A. So the first point projections A dash and A is obtained, and we need to draw the true length line at 35 degree to VP. So from here measure 35 degrees and draw a thick line, that becomes your AB. So at 35 degrees, right, with a length of 55 mm, right, you have to measure in this angle, right, from keep the protractor by aligning this point and this line, and you measure in this direction, otherwise you will not get. So that is the way to measure angle here, and this becomes your AB. Obviously it is top view, top view, that is 55 mm length, 55 mm length, and project it till the line A dash line, you will get the B dash. So A dash B dash is your front view. So here you see this is the apparent front view, and this is the true length line. It is obviously your top view. So that is the problem number 12, and in next problem we will see the point A is on VP. So that is the speciality of that problem. So point AB, a line AB 60 mm long lies in HP, right? And point and has its end A in both HP and VP, right? It means that point A is in HP and VP. It is obviously on XY reference line. Draw its projections when the line is inclined at 40 degrees to VP and parallel to HP. It is also like earlier case only. The only difference is it is the point A is on HP and VP. It is obviously on XY reference line. So try its projections, front view and top view, when the line is inclined at 40 degrees to VP. So draw XY reference line, and now this point, mark any point on XY reference line because it is on both HP and VP, right? So the line AB 60 mm long lies in HP. So students, the line itself is contained by HP, one that is containing A on XY reference line. So it means that when it is on HP, front view you should obtain on XY reference line. So that is the speciality of this problem. So this is your A dash and A, both points are same at the same point, and A dash and B dash, right, will be on the same XY reference line. So from here from point A, this is 40 degrees to VP, 40 degrees to VP, and from point A dash you draw the front view, right? This is your top view. So this is your top view with true length, so that is 60 mm. So that is 60 mm, 60 mm. Now project onto XY reference line to get your front view, because front view is contained by HP itself. So A dash B dash will be on XY reference line, right? So this is your front view and top view. So these are the 5 simple cases, and in next session we will see the procedure, how to draw, how to proceed in case of you have to both the angles. So that is the line inclined to both XY, both HP and VP. So that is the special kind. We will see it now. We will see it in next session, students. And there ends the simple cases of lines. We have seen a wide variety of problems. You please practice all these problems. It will be very handy to understand the next type of questions, next when the line is inclined to both HP and VP.